Hello, Pactrons community! This presentation takes you to the cold, remote areas of Alaska, where transportation can occur on river ice roads for up to 5 months out of the year. Ice roads are common transportation routes in many northern countries, even in today's world, the world of rapidly changing infrastructure. The motivation behind this project is to help people to stay safe while traveling on river ice. This can be achieved by taking repeated, accurate, and distributed measurements of river ice thickness. I have a talented and dedicated graduate student working with me on this project.
My graduate thesis research focuses on applying ground-penetrating radar to several river ice conditions in interior Alaska.
In many areas of Alaska, humans and animals take advantage of seasonal ice cover to move from one location to another. Our study site is located at the Yukon River at Tanana, a rural Alaska community that depends on a winter ice road across the Yukon River to connect to the state road system. Last winter, Tanana residents were testing 2 building techniques to find out the most suitable solution for their specific river situation. Here, I'm standing at the beginning of the packed ice bridge that was built by flooding initial ice surface with water and regularly packing the snow on top of the ice. The second bridge, called trench, was done by repeatedly removing the snow from the ice surface and smoothing the ice surface. At the time when we were there, trench bridge was easier to drive on, but it required a lot of effort to clean snow drifts from this road during the course of the winter. These were good examples of safe river ice conditions. River ice can also be unpredictable and dangerous, as ice thickness and ice strength vary greatly in response to river hydraulics and weather influences. Common potential hazards include wet cracks in the river ice, areas of open water, overflow, and structurally weak ice layers. My main point here is that accurate ice measurements during the entire ice season are absolutely essential for safe travel. Hand ice thickness measurements are traditionally taken with an ice auger. We also used an ice corer to get samples of river ice. Manual sampling is important, but it does require a great deal of time, strength, and effort. What we also brought with us to Tanana is a ground penetrating radar, or GPR. GPR technique is based on propagation of electromagnetic waves that respond to the interfaces between snow, ice, and water.
We used 2 ground-penetrating radar antennas with a MALA ground explorer system of 450 MHz and a 750 MHz. In these images, you can see that collecting a GPR transect involves one person pulling the antenna with the attached distance measuring wheel, while a second person carries the control unit to monitor the collection. Here we have a sample of example data collected on the Yukon River. On the left of the screen is a radargram collected with the 450 MHz antenna on the trench road. Our 17 attempted hand measurements are shown with the red lines at the top of each image. Hand measurements are limited to points, while the radargram allows for continuous measurement of the ice thickness. The light blue line on the upper image defines the transition from snow to ice. The darker blue line defines the ice-water interface. These lines, called horizons, are presented in an alternate way in the bottom image, where the light blue is the ice cover and the dark blue is the Yukon River water. The gray section is the space between the GPR transmitter and the snow-ice interface. These horizons can be output to data files with depth of each horizon at every scan of the GPR. Regression plots were created for each GPR transect collected. This plot compares the hand-measured ice thickness to the ice thickness calculated using a model average ice velocity from the GPR data collected. Overall, the Yukon River had a high R-squared value of approximately 0.9 on the trench road, compared to an R-squared value of 0.6 on the Tanana River in 2020 and 0.07 in 2019.
While GPR performed very well on the Yukon River ice bridge, we encountered some challenges in other locations. We will tell you about those case studies next time. I would like to thank everyone involved in this project, especially residents of Tanana, for sharing their knowledge and being open to new ideas. Thanks for watching!